Welcome back to the tutorial on using Python to make plots. Today what we're going to do is we're going to plot a function, but we're going to do it by making points that correspond to the values of that function and then plotting those so that we can see how data works in Python. And to make it a little bit more clear, hopefully, what's going on, we're also going to see the process in Excel, which is why I've got Excel pulled up here, because I think at this point, hopefully, we have a good idea of what data looks like in Excel, and so we'll see how it looks over here in Python. We're going to plot a sine function, all right? So let's just make a note of that. We want to plot a sine function. I guess we can spell it out all the way. All right. What we would normally do then in Excel is basically have x and y and plot x versus y. So here's x. How about it runs from 0 to 100? And so we know how to do this. I can create a pattern that I want to propagate, and then I can just drag this down. And I'll do so until I get to 100. And again, there's many ways to do this. This is just one. Now I have a list of numbers, 0 to 100. That's our x values. That's going to be half the coordinates we need. In Python, if we wanted to do that, well, we could simply just make a list. So x equals 0, 1, 2, 3, 4, and so on. But that's going to take a really long time, and it's super painful. So wouldn't it be nice if we could somehow generate a list of data that just automatically goes 0 to 100? So the easier way maybe to do this is to just use a function. I'm going to say I want a list, and I want it to generate numbers along a range. And then remember that basically the way that we said lists work is that we call 0 as the first one and count from there. And so because of the way that programming works, it's always going to be exclusive. And so it's not going to include the last number that we give. So if I say x is list range 0 to 101, and then I say, let's just look at what x looks like, what we see is I have a list from 0 to 100. All right, so at this point, I basically have the x data. What we'd like to have next is the y data. So in Excel, we would simply just say that this is going to be equal to sine of x. And then we make this apply to every single one of these cells. And now I have my x and y data. We could do the same thing here. What we would like to be able to do is multiply each one of these numbers by a certain function, or perform a certain mathematical act on each one of these numbers. There, again, are many ways that we could do this. We could decide that we want to use control loops and things like that, but I think that's beyond what we want to do here. Instead, let's use a package or a library or a module, lots of different names for this, in Python that will help us do this in a way that feels more natural. And so what we're going to do is we're going to import a library called Numpy. And all we're doing when we say import is we're pointing at basically there's a whole series of functions that somebody has already written. And we're saying, I'd like to use these functions now. The same way that range was a function and we invoked it. The function we want to use is not part of Python alone, and so we need the new library. So this means we're going to load the library Numpy. And that lets us now invoke functions from Numpy. So I want to create y values, and the way that we were going to create y values is basically take all the x values and take the sine of those. And so what we could do is we could say numpy dot sine. So this is saying sine is our function, and numpy is where to look for that function. And then I just simply put x in here. Now, we can see this isn't going to quite work because the way that Numpy is written is to only act on what is called an array. Okay, and so we need to convert x into an array first, and their arrays look a lot like lists, and we'll see that actually in just a second. So x, the way to do this is to make it a NumPy array of x. And we're going to change then, so now we're making x into an array. Arrays are a lot like lists, just there's some small differences, and one of the differences is that NumPy knows how to handle an array, and when I say something like sine x, it knows that I mean apply that function to every single value in here. And so then, just to see what we get, we'll say print y. Okay, so let's go ahead and run this. And what you can see is that this looks a lot like a list. It's a little different because we don't have the commas between each one. So this is an array. And then here's y, 0.84, 0.909, and you can see I'm getting the same numbers that I would have gotten here. And so now I have x, which is my x points, and y, which is my y. So if I wanted to plot x and y, what I would do normally is say insert plot like this, and you can see I plot 0 to 100 on x, and I have a sine function. Of course, it looks a little jagged, and the reason is that there's not enough resolution. And so what we could do is, instead of having this in terms of 0 to 100 in just straight up numbers, let's go ahead and convert it to radians. So let's call this x radians. And so how we do this is that we just simply divide the numbers in x by 2 times 3.14159 by pi. And then I go ahead and propagate this down. So now I have a new x, and then the y, I guess we can just say y radians, just to make our life easy, is going to be equal to sine of the radians value. And now, if I plot these two, what you see is that I have a much more smooth plot. So the issue with this is right now that I made a typo, and it should be 3.14, and so let me just change that and then propagate it down. All right, now I have something that looks more like the sine function that I would normally expect. Okay, so I have x in radians and y in radians. So let's go ahead and just apply that here. You can see that once I've made the x value into an array, I can just apply functions to it. So let's go x radian is going to be equal to x divided by 2 times, it turns out Numpy has a version of, or NumPy has a version of pi. So now I have this, and what I could do is make y radian, if I wanted, equal to numpy.sine of x radian. Now I have x and y radians, which are the same as the values here, and so let's just print those so that we can see them. Now you can see my x values follow similar to what I see for the radian values. And when I scroll down to find the y values, 0.15, 0.31, they're the same, right? And they should be the same as what we saw before. So I'm set up now to plot something that looks like this. It turns out that in Python, out of the box, we can't just plot, all right? And we need to import a new package. And the package that we're going to use is going to be matplotlib. And specifically, we want like a sub-library out of this, which is called pyplot. So I want pyplot like this. Now, it turns out that like I don't want to have to write matplotlib .pyplot whatever I want to do every single time. So we can rename things when we bring them in. And so I'm going to say I want the pyplot section of matplotlib, but I'm just going to call it PLT. All right, so now we've imported pyplot, but we can just call it using PLT. And so we'll see how this works now when we plot our data. Okay. I don't want to have this printed out every single time, but maybe I'd like to go back and look at the data. So you can just put a comment in front of it, and now when I run this, you'll see it won't print things anymore. But I don't have to retype it, because if I wanted to say like, oh, I just want the X, I can delete this, and I can look at it again. And so that's kind of nice, being able to comment things in and out, we might say. But what I really want to do is plot these two things. And so the easiest thing for us to do is to say PLT. Remember, that's what we called matplotlib pyplot, was PLT. So I want to invoke that and say, I want to plot. Let's plot X radian and Y radian. And so I'm supplying an X and a Y value, whatever variables I had named them is fine. And then I need to say that I would like to actually see the plot. So plt.show with an empty argument for that function, and that's all we need. When I hit go, then what you'll see is now I have this plot. And it looks pretty similar to what we see over here. Some differences, you can see the defaults are that there's a little bit of room on the left and the right of the data, whereas the Excel defaulted to having 0 be the start. We can choose to change all that if we want to down the line, but that will be maybe for another video. For right now, let's just cover a few of the very basics. So when I say plot, the default then is to have a line that joins together my points. There's lots of other ones that we could invoke, like scatter. Now I'm going to have points, just like a scatter plot. I could have chosen to have bar, and then I'll have bar plots, right? Just like we're used to seeing. And so this is how you change the type of plot that you want. We want the regular plot. I could change something about this plot. Like maybe I don't want it to be blue, which is the default, but I would like it to be red. Now I have a red line. Maybe I don't want it to be a solid line, but I could have something like a dash line. I would use the keyword line style and equaled dash. Oh, so I got an error because it turns out dash is not the correct one. It's dashed. And the issue, I mean, there's a lot going on here, right? But basically at the bottom it says dash is not valid for line style, which can also be abbreviated LS. So I could either use this for solid, that for dash, this for dot dash, none, solid, dash. So this is what it's saying. I should have used dashed. So dashed. Let's have a look. Now I have a dash line. I can make this line wider if I want. I use the keyword line width. Let's make it 4 point, or 4. We don't have to include point, we just use a number. And this number could be a float, so maybe I want it to be 1.5. So floats are ones that have decimal points, and there it is. And so this is how we control the appearance of this line. Okay. Similar arguments could be made for things like scatter and bar and things like that. Something else we could do is, what if I said instead of y radians, I want the cosine function. Let's call it cosine of x this time. That's going to be numpy.cos and x radian. And now I have a new variable that I could choose, which is cosine x. And then to this, I can just add it. PLT plot x radians and then cosine x. And if I don't add anything else, it'll show up as the default of blue. And now I have cosine and sine plotted together on this plot. And of course, you could like plot other values versus each other, right? So what if I wanted PLT dot plot and then I had y in terms of radians and cosine x. And you'll see, now here's the new one, right? Orange. That is the next default color. So it will opt to choose them separate from each other and put it on here. What if I thought to myself like, I don't really want this plot on that plot. Well, what I could do is just remove that. I copied it or cut it, and so I'll paste it. And now what you'll see is that I showed one plot that's going to have both the sine and cosine involved in it. And then I showed that, and then I started a new plot, and then I'm going to show that. And what you'll see is that now I have two plots, one that is sine and cosine, and one that is sine versus cosine. And it should be a circle. The aspect ratio is forcing it to not look circular, and that's something we can also talk about if we want later. Last thing, you'll notice that these axes don't have names and the plot doesn't have a title. And those are the most basic things. Even before we get into thinking about design, we have to tell people what we have. And so let's go ahead and do that. We can say PLT. I want the X label, and our X is going to be radians. And then I want a Y label, and that could be amplitude. And then finally, I might want the title. And the title is going to be cosine, how about sine and cosine of X. And then we don't need this plot anymore, so let's just show this single plot. And there it is. I have a title, goes at the top, in the middle, that's the default. And the title for the Y and the X is also to put them in the middle, is the default. And so now we have a simple plot here, and if you wanted, you could take a screenshot, share that with somebody else. You could export it. We'll worry about that in a future example. But hopefully you can see how I get similar data structures to what we see in Excel and similar plots to what we see in Excel. And all that's happening is that we're holding these data structures in variables, and then we use those variables to plot. And that's all for right now.